All right, so that's the idea of a stateless packet filter. Obviously, they're very limited because they don't have state. And it makes it hard to enforce a policy without keeping state about each connection. So a stateful packet filter is more typical today. A stateful packet filter now keeps some information about the set of connections that are currently open. Maybe a list of the connections are currently open, maybe some information about each, and now can use that information when making a decision about whether to allow or block this packet. Okay, so now it becomes much simpler to enforce blocking of inbound connections because we can remember all the connections and whether they were inbound or outbound. And then when we see a packet coming in to the firewall, we can look up and see which connection is associated with and see whether that's something that should be allowed or not. So here would be an example of a rule that you might be able to enforce with a stateful packet filter. In this rule, you might allow all TCP connections from host 4.5.5.4 to host 3.1.1.2 if it's to port 80 on 3.1.1.2. Okay, so this rule would allow that one client host to contact a web server, because port 80 is for the web, this one particular web server at 3.1.1.2. Okay, now the firewall, the stateful packet filter, would keep a table of all the active connections. And then when the firewall sees a packet, it checks whether it's part of one of these active connections. And if so, forwards it. If not, if it looks like something is attempting to establish a new connection, it checks whether that connection is allowed by looking at the rules, like this rule, and either blocks the packet or allows it and adds it to the list of active connections. Here'd be another example rule. Allow anyone to connect to this particular web server, port 80 on 3.1.1.2. Now, for some purposes, it's reasonable to limit specify matching on these rules, not only by the source and destination IP address, but also by which interface of the router the packet is seen on. So which direction through the router it's going, like is it going from internal host to external, or is it going from an external host to internal? So there's that slash there. The slash int means packets that come from an internal host and are destined to an external host. And what this does is it ensures that IP address spoofing won't fool the rules about which direction this connection is going. Okay, so this rule would allow all outgoing web requests to one particular server. And you can have a rule set. You can have a set of these rules. Here's two things that are allowed. Any connection from an internal host to any external host, that's allowed. Any connection from any external host to port 80 on this one internal web server that we know, this one machine that we know is intended to run a public-facing website. And you might have a long list of these rules. Okay? So that'd be stateful packet filters. I see there's a question, what if the attacker DDoSes the entire firewall? Well, the attacker can try to DDoS the firewall by sending a lot of packets and maybe overloading the firewall. Depending how the firewall is implemented, that might either take down your entire internet connection, so that nothing gets forwarded if the firewall is part of a router. And that would be safe from a safety perspective, but would also mean that you can't use the internet. Or it might take down just the monitoring service, and then all packets might get forwarded, and that would be unsafe. You probably don't want that design.